Well, today I'd like to have a look at the Shure lithium battery charging extension board, which is an accessory sold for the Shure Wondom JAB series of amplifiers that are a Bluetooth amplifier. These things are relatively cheap. They're about $8 from Parts Express, and I want to see if it can be used as a standalone battery pack board that will hold some 18650 batteries, and that will be a standalone board for charging and battery management. This thing is built on a BM 3451 series chip, so the chip is on board. And the BM 3451 chip is a battery management and protection chip. And you see we have got a couple of JFETs here, so really we should be able to use this as a standalone board. Now what the GAB amplifiers have built on board to them is they have a voltage or a constant current source on them built in, so that if you are using a voltage higher than 12 volts, and I think some of the boards there, the GAB1 board I think will go up to about 19 volts. It will provide you with a 12 volt 1 amp source for this board to charge the batteries. And there's also the charging lights are on the board as well. But I just wanted to see if we could feed a power source to this and charge the batteries safely, and then use this battery pack to power some other different types of boards other than the Shure JAB series. So what I've done here is I've got on the setup I have the board with 3 Samsung 18650 batteries in it. I've got the output of the batteries hooked up here to this voltmeter, and you can see that they're sitting right now at approximately 10.8 volts. On the other side here, these clips, what I have here is I have power coming from my lab power supply into the battery pack, and I just have the positive lead here split so that I can measure the input current coming into the charging board. Let's go ahead here and set up the lab power supply to deliver what we want. First thing I'm going to do is unhook the lab power supply here, and I'm going to go ahead and short these 2 leads together so that we can set the limiting current. We're going to set the limiting current here to 1 amp, which is about half C for this for these batteries. So let me just see if I can do this here. Okay, you can see the power supply here. Make sure this is all turned off. We'll go ahead and set this. Let me take this off of here. We'll go ahead and set this current limiter to 1 amp. If you guys don't have a lab power supply, these things are indispensable for doing any type of solid state troubleshooting. Alright, there we go. We've got it. Now we've got it set to a current limit of 1 amp. We'll go ahead and unplug these clips, which takes it out of the constant current mode, puts it in constant voltage mode, and we'll set this for a maximum voltage of 12.6 volts. Okay, so now we have the lab power supply set up. And let's get back set up here. Okay, we're all set up. The way that lithium-ion batteries charge is that they charge in two phases. There's a constant current phase, and that's usually set at half C, and half C for this battery is just over 1 amp. So we're going to go ahead and use 1 amp for this. And then when the battery reaches its target voltage, in this case 12.6 volts, it'll switch over to a constant voltage and a constant voltage charging mode. And at that point, the current will start to drop over time until it reaches a set point, which is usually around, I think, about 0.2 C, but I'll have to check on that. And then the battery is fully charged. Okay, so let's go ahead and hook this lab power supply back up again. All right, so what we're going to be looking for here is the voltage on the batteries, and what we're going to be looking for here is our charging current. Let me just make sure that I haven't done anything stupid. Everything looks like it's hooked up correctly. I'm going to go ahead and turn on the lab power supply, and here we go. Let's make a little adjustment here so we're up to 1 amp. Okay, so now we're charging at 1 amp. The voltage on the batteries is 11.08 volts. Batteries here are not warm, nothing's smoking, everything's looking pretty good. If we go back up here to the lab power supply, you can see we're in constant current mode. We have our voltage limited set to 12.6 volts. We're not at that point, so it's delivering current to try to get up to that 12.6, and we've limited it to 1 amp. Let me just fix this here a little bit. There we go. So once this reaches the target of 12.6 volts, this will come off of the constant current mode and we'll go into constant voltage mode, and we'll see over time the current will drop, and then when it reaches the finish point, then we'll shut it off. Okay, so this is going well. This is all well and good. The other thing I wanted to try, though, is to see if I could use one of these lithium battery charging wall warts. This is a lithium battery charger, lithium-ion battery charger. It has an output of 12.6 volts DC at 1,000 milliamps. So what I'm going to go ahead right now and do while I have this all hooked up is I'm going to turn off the lab power supply and plug in this wall wart here, and we'll see how this performs and if we can safely charge this battery pack with this wall wart. Okay, so we've gone ahead and turned off the lab power supply. Plug this in here. Plug this into the batteries. You can see that the light here has changed from green to red. We're drawing 0.9 amps. Everything's looking good here with the battery. So while I've got this here, I think I'm just going to let this sit here and charge on this wall wart for a while and see how this works. Okay, we're back. I don't know if you can see this here, but we've been charging this lithium-ion battery pack with this wall wart charger, and the light here is turned green on it. So it's finished doing its thing. We're reading a voltage coming off of these batteries at 12.48. I'm not too concerned about that. This meter is not very accurate. I'm going to hook it up here to the lab power supply, and we'll get a better reading of what the actual voltage is. And we're down to a current of 0.34 passing through on this. Looking at the spec sheet for these batteries, on a standard charge is done at 1/2 C, which is 1.25 amps. For each cell at a voltage of 4.2, so that would be 12.6 for all three. And then the cutoff is 125 milliamps. So you can see here we're at 330 milliamps, so we are not all the way fully charged, assuming that this meter is correct. I think this meter is fairly correct because it matches my lab power supply pretty accurately. Well, anyways, we'll go ahead and disconnect this, and we'll hook it up to the lab power supply, and we'll see what the numbers are on the lab power supply. All right. Well, it looks like this is done. The lab power supply is at 12.6 volts, and it's basically stopped charging. There's zero current coming through there, and which matches with this thing here. So it looks like this meter is about 0.2 volts off. So this is very successful. I mean, we can go ahead and charge this board with a wall wart type of lithium-ion charger. The batteries aren't hot. Everything looks really good here. So I'm going to go ahead and end this video. And so this looks like it's a success. So we can so I can go ahead and use this Shure lithium battery charging extension board outside of the GAB amplifier series, and can use it as a standalone charging system and battery protection and battery management system, with the addition of some 18650 batteries and a wall wart charger, a 1 amp charger. One other thing I'll tell you about this, we're charging this at 1/2 C, but this also has a rapid charge. These batteries are able to take a rapid charge at 4 amps. So that's basically 2 times C. So I'm really pleased with this. This is a very cost-effective method. It seems to be a very well built protection circuit and battery management circuit. I think this might take the place of some of the old blue battery packs that I was using in my builds. Alright guys, hope you found this interesting, and we'll talk to you later. Thanks, bye.